Hi students, today we will discuss about the product of vectors. Product of vectors. So here the product of vectors are of two types, and among them the first one is scalar product or dot product. Suppose here vector A and vector B. We take these two vector A and vector B. So the scalar product of these two vectors, scalar product of these two scalar product of these two vector means vector A dot B. So here the scalar product is represented such a way that is the dot A dot B. That's why the name also dot product. So now question is, why the name is the scalar product? So here if you do the scalar product of these two product, then we get a result. This result is a scalar quantity. This is scalar quantity. So the scalar product of two vectors represent a scalar quantity. If I give one example, suppose the work done. Work done means the scalar product of force and displacement. Here F is a scalar quantity and as well as S also a scalar quantity, and in between them when we do that F dot S, that is the scalar product, then you get the work done. Work done is a scalar quantity. This work done is a scalar quantity. That means we can say here the scalar product of that two vector give us a what? Scalar quantity. That's why this product is known as the scalar product. So scalar product, here the product of two vector, the result will be a scalar quantity. That's why the name is a scalar product. Now next things, how can we represent this scalar product? Suppose this is the vector A, direction of vector A. This is vector A and this is vector B. This is vector B. And the angle between these two vector is theta. So A vector dot V vector, A vector dot V vector, that is equal to A B cos theta, that is magnitude of A, magnitude of B into cos theta. Here magnitude of A, this is scalar quantity, magnitude means scalar quantity, magnitude of B also scalar quantity, and cos theta also scalar quantity. That means this total thing is a scalar quantity. So such a way the scalar product can be represented, that is AB cos theta. Now we know that a vector quantity can be represented such a way, that is suppose vector A, if you write the vector A is equal to x1 I cap plus y1 j cap plus z1 k cap. I hope you know about that a vector quantity can be represented such a way. What is the x1, what is y1, what is z1? What is the I cap, j cap and k cap? I cap is the unit vector along x-axis, j cap is the unit vector along y-axis, and k cap is the unit vector along z-axis. So x1 is the magnitude of A along x-axis, y1 is the magnitude of A along y-axis, and z1 is the magnitude of A along z-axis. So such a way a vector quantity can be represented. And similarly, if I write the vector B is equal to x2 I cap plus y2 j cap plus z2 k cap. So these two vectors are represented such a way. Here x2, y2 and z2 means the magnitude of b along x-axis x2, along y-axis y2, along z-axis z2. Now if I say how can we product these two vector a and b, now we have to discuss about that. So here this is the x-axis, y-axis and z-axis. I cap is the unit vector along x-axis, j cap is the unit vector along y-axis and k cap is the unit vector along z-axis. So here if I do that, the dot product in between the unit vector at first. So suppose I dot I, that means the dot product of I with itself. What will be the value? We know that a dot b is equal to ab cos theta. Just to discuss about that, that is a dot b is equal to ab cos theta. This formula if you use here, so I dot I means here I cap magnitude, then again I cap magnitude into cos theta. So I cap dot I cap means magnitude of I cap, again magnitude of I cap into cos theta. So this is the direction of I cap, again this is the direction of I cap, because two vectors are both are around same vector. So I cap with itself, what is the angle between them? 0 degree. This is the I cap and again this is the I cap. So I cap with itself, the angle is 0 degree. So here magnitude of I cap means what? 1. Again the magnitude of I cap means what? 1, because we know that the magnitude of any unit vector is 1 and the theta is here cos 0 degree, theta means 0 degree. Why? Because this is the angle between I cap with itself, both are I. So what is the value of cos 0? 1. So here you can write that is 1 into 1, cos 0 means again 1, that is equal to 1. So that means I cap dot I cap, that means the dot product of I cap with itself, that is equal to 1. And similarly we can prove that j dot j cap dot j cap also 1 and k cap dot k cap, that is also 1. That means we can say that the dot product of any unit vector with itself, I dot I or j dot j or k dot k, all are is equal to 1. And if you calculate the dot product of in between two different unit vector, suppose that is I dot j, that means the dot product in between two different unit vector I and j. So again we use the formula, that is a dot b is equal to ab cos theta, that formula. So here I dot j means ij cos theta. So magnitude of I cap, again magnitude of j cap into cos theta. So magnitude of the I cap is 1 because the magnitude of unit vector is also 1. Similarly j cap also 1 and cos, what is the value of theta? This is the I cap, this is the j cap direction. So this angle is what? 90 degree. We know that the angle between x-axis and y-axis is 90 degree. So the angle between I cap and j cap is what? 90 degree. So at the place of theta you can put that is 90 degree. And what is the value of cos 90? 0. So this total things will be 0. So I cap dot j cap is equal to 0. That means we can say the dot product between two different unit vector is 0. If you write that, if I say that what is the value of j dot k, so dot product between different vector is 0. If I say what is the dot product between I dot k, always 0. So as a whole we can say that the dot product between two same unit vector is equal to 1, I dot I, j dot j, k dot k 1, and the dot product in between any two different unit vector I dot j or I j dot k or I dot k or j dot k, anything, dot product in between any two different unit vector is always 0. Now here we do one dot product in between these two vector, vector a and vector b, vector a and vector b. Vector a is this one, x1 I cap, y1 j cap plus z1 k cap, vector b x2 I cap plus y2 j cap plus z2 k cap. If we do the dot product in between these two vectors, suppose here a dot b, a dot b means a means this one, we write it x1 I cap plus y1 j cap plus z1 k cap, dot b means x2 I cap plus y2 j cap plus z2 k cap. We write the vector a dot vector b. Now simple algebraic rule, this is multiplied by these total things. So at first x1 I cap, then they write these total things, that is x2 I cap plus y2 j cap plus z2 k cap, then write plus y1 j plus y1 j cap, again we write this one x2 I cap plus y2 j cap plus z2 k cap, again plus z1 k cap, z1 k cap, again we write this total thing x2 I cap plus y2 j cap plus z2 k cap. That is simple algebraic rule. This one is totally multiplied by this one, again plus y1 j multiplied by total this one, again plus z1 k multiplied by this total these things. Now I1 dot I1 means I1 dot I1 means we know I dot I means 1, so 1 into x1 into x2 means what, you can write here x1 x2. I dot j means what, 0, I dot j means 0, and I dot k means also 0, so these two term, the dot product with this is 0, so we don't write this one, plus for this j dot I 0, j dot j means what, 1, because j and j both same, so y1 into y2 means y1 y2, and j dot k means 0, so we will not write, plus these things k dot I 0, k dot j 0, because the unit vector, two different unit vector, we know that dot product of two different unit vector is 0, so k dot I 0, k dot j 0, but k dot k means 1, and that is z1 into z2, so z1 z2. So this is the a dot b, this is the a dot b. So here such a way the product of dot product of two vector can be calculated. One another example, suppose vector a is equal to 2I cap, 3j cap, 4k cap, and vector b is equal to suppose 3I cap plus 2j cap plus 2k cap. So I say you to calculate the a dot b. How can you calculate? A dot b, here at first I dot I 1, 2 into 3 6, I dot j 0, I dot k 0, okay, this I part is vanished, plus j dot I 0, j dot j 1, 3 into 2 6, so 1 into 6 means 6, and j dot k 0, again for this k dot I 0, k dot j 0, k dot k 1 and 4 into 2 means 8. That means 6 plus 6 plus 8, that means 6 is 12 plus 8, that is 20. I repeat once more. At first I multiply this thing with the total things. So I dot y 1 and there is 2 and 3. 2 into 3 means 6. I dot j 0, so nothing. I dot k 0, nothing. Okay, this term is over. Next terms. So we multiply this totally with this. So j dot I 0, j dot j 1 and 2 into 3 means 6. Okay, and j dot k 0, so no. Now we multiply this with these total things. K dot I 0, k dot j 0, k dot k 1 and 2 into 4 means 8. So 6 plus 6 12, 12 plus 8 20. So 20 is a scalar quantity. Scalar quantity. So here the dot product or scalar product of two product, the result is a scalar quantity. So such a way you can calculate the scalar product or dot product of any two vectors.